Hierarchy in the sense what? What is the different functionality that I have in the next level? Drivers is specialized routines that passes the test cases to the subsystem. So sandwich is a strategy in which top level modules are tested with the lower level modules at the same time, lower level modules. Guys, whatever the sandwich integration that we have, this is for the management level. This is helping for the management level, so not for the coders. Hello everyone, I welcome all of you to the yet another interesting chapter. It's going to be an integration testing. So in my previous sessions, I have discussed what exactly the different levels of testing. In that, I have spoken about integration testing. So let's understand what is that I have in this chapter. So guys, the agenda for the day, I will be discussing the introduction part. All right, so you will be getting to understand the basics of integration testing, and then followed by what exactly functional decomposition of integration. So that's what you will be understanding. What exactly I will be calling it as a decomposition. So you will be understanding in detail with an example. So the next topic which I'm going to discuss is top-down integration process. So when I say integration, so I have different methodologies which I will be showing you all in this session. So the first one that I'm going to explain is all about top-down. So please remember top-down integration process. And what will be the problems if I use top-down integration? In the same way, I will be discussing the bottom-up. So along with that, I will also discuss the issues which I have in the bottom-up integration. So after that, I will be discussing some of the important topic in the same way, like, how I have top-down and the bottom-up. I have one more that is going to be a sandwich integration. All right. So along with that sandwich integration, so definitely you will have some of the issues, that is pros and cons of this topic, so which I will be discussing in this session. So in total, you will have 3 topics in this session: top down, bottom up, sandwich. For all these 3 topics, I will also discuss some of the drawbacks or the issues that I have. So guys, this is the agenda for the day. So stay tuned and understand the topic. So watch the session till the end. So let me start with the first topic, that is introduction. Listen to me and understand this point, what I have. So to test the interfaces, please observe this word. To test the interfaces and interaction among separately tested units. What exactly the meaning of interfaces and the interaction? Say for example, I have 2 units. Remember, this is a login module and this is a homepage module. Imagine and treat like that. So if I want to join this, so for that, I need some interface to connect to both the units. So this is what I will call it as an interface, which comes between 2 important units or 2 units. So that is what I will call it as an interface. So what is the next one? Interaction. How exactly these 2 are interacting. So to understand this, so please remember, I have 3 different approach. The first one that I have is based on functional decomposition. How do I understand this? How exactly I am having the interface and interaction among 2 different units? So I will be understanding with based on functional decomposition. The second one that I have is based on call graph, and the third one that I have is based on paths. So this is the 3 important topics which you will be studying in this entire chapter. Please remember this. The first topic what I have is functional decomposition. So it's a very simple and easy topic. I will be doing and I will be explaining this in this session. The call graph and based on path is what I will be doing it in the next session. So guys, let's understand what exactly this functional decomposition is all about. So moving forward, so please understand the next topic is functional decomposition. It's very simple. So please remember, create a functional hierarchy of a software. What exactly it means? So let me brief out. Let me explain this concept now with a diagram. So please observe. I have a main software. Imagine the calendar is a main software. So I have to consider this, and then I have to create the hierarchy of this software. Hierarchy in the sense what? What is the different functionality that I have in the next level? So after that, the next level, after that the next level. So this level by level is what I will be calling it as a hierarchy. So for each and every software, whatever you have, so you have to create the functional hierarchy of that particular software. So representing the software in this form, okay, is the most important thing. So this is what we call it as a functional decomposition. Point number one. So hope you understood this. Creating a functional hierarchy of the software. Yes, we have done that. So what is the next point that we have? Problem is, please understand, the problem is broken up into independent tasks or units or functions. That's a very important thing. So please observe here. What is that I have? So problems are divided into independent tasks or units or the functions. You cannot say that this function is doing both the tasks. If I am dividing it, so make sure that you will divide that function or that task. It is performing only one task. So that's why I will call it as an independent unit or independent task. So you have to divide your softwares in such a way that so all the functionalities are divided separately and it is independent. So that is the second point that you need to understand. So fine, the units can be run either sequentially or simultaneously. Sequentially in the sense one by one, simultaneously in the sense parallelly. So that's what you need to remember. So what is the first thing? You have a software and you're trying to decompose in the form of hierarchically. Okay. So after that, so what is the next important point you will remember? So you need to remember that the problem is broken down into independent units. And then after that, the units can execute. So either run sequentially or simultaneously. Sequentially in the sense one by one. So what is the meaning of it, sir? Say for example, this is my software and all these things are the units that I have. So independent units. Okay. So first I will execute this. Next I will execute this. Next I will execute this. What do you call this as? Sequentially. One after the other you are executing. But simultaneously in the sense parallelly you are executing this. So that is the most important point that you need to understand here. Then what is the next point that you have? So this is used. Where exactly this functional decomposition is using? So we are using this in the planning phase and analysis and design. So we are using this in the planning, analysis and the design phase. We are using the functional decomposition in the planning phase, analysis phase and the design phase is what you need to remember at this point of time. Alright, so this is all about the brief idea about the functional decomposition. So guys, please remember, decomposition is based on some of the concepts. We will decompose. So you have seen this, right? So we are decomposing. So composing in the sense you are putting everything and you are making one, okay, but you're not doing like that. So you have taken one main thing and you are dividing it into separate parts. So you are decomposing, you're separating, you're spreading, okay. So this can be done in three ways. The first one that I have is top-down approach. The next one that I have is bottom-up approach. And the last one that I have is sandwich approach. So I have three different ways to decompose the software. The first one is top-down, the second one is bottom-up, and the third one is sandwich. Let's understand one by one to understand each and every concept, how exactly I will be decomposing the software. The first one that I have is top-down integration process. What exactly happens in the top-down integration process? So please understand, if you just look at the diagram, I think the concept is very simple. You don't have to worry much. What is that you have? So please observe, first you are taking the main function or the main program. Then after that, the next level. So what is the next level that I have? So this is my next level. So you will integrate with this. You will integrate, you will start integrating with this. Then after that, so you will come to this. After that, you will come to this. Yes or no. So you will start integrating from the main program and then you will come down. So this approach is what I will call it as a top-down approach. This approach is, I will call it as a top-down approach. So please understand, when it comes to the top-down integration, I am integrating the units. How are you integrating? So first I will consider the main program. Then after that, the first level, I will start integrating it. Then I will come to the next level. So I will be start integrating level by level from the top. That's what you need to understand here. So hope this diagram speaks very well to all of you. So guys, please observe here. This is the first level. Then after that, I'm coming to the second level. Hope you are able to see this. Then I'm coming to the third level. So one by one, I will start integrating this. Okay, let's understand this very clearly. So I have an example for all of you. So please observe here. So first I have calendar. Okay, that's the main function that I have. Then after that, I will integrate this sleep. So this is the unit that I have. Then after that, I will integrate weekday. Then after that, I will integrate get data. Like this, I will be integrating one by one. So once I'm done with this level, I'll go for the next level. It goes on. That's what you need to understand. This is how we are performing the top-down integration. So let's check what are the points that I need to remember with respect to the top-down integration. The first point that you need to remember with respect to the top-down integration is focuses on testing the top layer. It focuses on testing the top layer, whatever you have. After the main program, so please observe here. So after this main program, it focuses on testing this top layer. This is what I will call it as a top layer, the immediate layer of the main program. That's an important thing that you need to remember. And it controls the subsystem first. So first it tests. Please observe, focus on testing the top layer, or it controls the subsystem. So that's the first layer is what I will call it as a subsystem or top layer. That's what you need to remember here. The main or the root of the call tree. So please understand. So this is what I will call it as a root. This is what I will call it as a root, or I will call it as a main program. So this is what you need to remember. So fine. What next I have? General process is how exactly in top-down approach it happens, in top-down integration approach. So remember to gradually add more subsystems that are frequently used or required, already been tested, the subsystem when testing is application. What exactly it means? Remember and listen to me carefully, point by point. Gradually, to add gradually. So what is the meaning of gradually? So please listen here. First, I will add this. Then, after that, I will add the second one. So, after that, I will add the third one. So, gradually, I started adding one after the other. I'm adding the units. So, what unit? So, that is the most important point that you need to check here. So, to gradually add more subsystems, this first layer is what I will call it as subsystems. Gradually, to add more subsystems that are required or referenced by already tested subsystems. When testing the application, whatever the subsystems or the units that I'm adding, so please remember which is already been tested. So that's the most important point that you need to remember. If I'm adding, so I should have already tested it. So that's what I need to add. So that's the most important point that you need to remember here. The next point is do this until all the subsystems incorporate into the test. I should repeat the same step until I have all the subsystems. So please remember, I have stopped only for the third one. So I have to do it for all the subsystems. Once I get all the subsystems, till I get lost the subsystem in my integration, I have to repeat this step. I have to keep on adding, so which is already been tested. So that's what you need to do it. Next slide. Stubs are needed to do the testing. Very important point here. So what is the meaning of stub? What is the meaning of stub? Dummy unit is what I will call it as a stub. Sir, what is the meaning of stub? Let me give you an example here. Remember, I have a bike. Okay. So I'm testing the accelerator. Okay. I'm testing unit by unit. So first I'm testing the accelerator. If I want to test the accelerator, so I should have the clutch wire. So here, need not to have the original clutch wire. I will have the dummy clutch wire, which will exactly function like a clutch wire. Hope you are able to understand. I am testing the accelerator. To test the accelerator, I need the clutch wire. Let's imagine like that. Okay. So I need the clutch wire also, but you don't have to have the original clutch wire. You can have the dummy clutch wire. But remember, this clutch wire should perform exactly like the original clutch wire. So this is what I will call it as a stub. In the same way, guys, please observe here. If I want to test any one of the system here, let's imagine I need to test this. Okay. So if I want to test this, I might require some other stuff, other functionality to perform. So for that, I don't want that original one. So for that, I will create some dummy piece of code, which exactly works like that. So that is what I will call it as a stub. Okay, let's check the definition what you have. Stubs are needed for this testing. Okay, fine. When we are performing the top-down integration, the most important thing that I need is stubs. So fine, what is stub? Let's understand this. A program or a method, so please understand, a program or a method that simulates the input and output. Simulates in the sense what? Exactly, it gives you the inputs and output, but not the actual input and output. So that's what you need to understand. Simulates the input and output, so or the functionality of missing subsystem. When I'm testing, I will not have the rest of the system, the missing subsystem, but I should have that missing system also. So for that, what is that I need to do? I will fill it with the stubs. That's what you need to remember. So I should have the missing subsystem. So all those missing subsystems, I will be replacing that with the stubs. That's what you need to remember here. So missing subsystem by answering to the decomposing sequence or calling subsystem and returning the simulated data. That's what you need to remember. Say for example, let me explain one more time. So guys, if I'm testing this, I will not be having all these things. So what I will be doing, I will have the stubs here. I will have the stubs here. So that's what you need to understand. Why do I have stubs? So to simulate the input and output, actually what exactly that I am supposed to get. So that output, so it will give you. But actually you're testing this. You're not testing all these things. That's what you need to remember. That's the idea behind the stubs. So fine. So you need that, you need the stubs for the testing. That's a most important thing that you need to remember when it comes to the top-down approach. This is one of the points that you need to remember when it comes to the top-down approach. So fine, moving forward to the next one. Writing the stubs can be difficult. This is one of the important points. Yes, you said, sir, for a top-down integration, you need stubs. But writing that stubs is difficult. That's the most important point that you need to remember here. Yes, why it is difficult? So especially when the parameters passing is complex. When I'm passing the parameters, it is quite complex. That is one of the most difficult tasks that I will be having with the stub. And the next one is stub must allow all the possible conditions to be tested. What is the meaning of it? Stub is actually acting like a unit, but that stub also should allow me to do all the possibility of tested. Say for example, I'm checking the accelerator. I need to perform the declutch. I need to give the clutch and I need to declutch it. So it should also perform that all the possibility, whatever I'm doing with the accelerator, whatever it is necessary from the clutch, so it should support for me. So that is one more important point that you need to remember. Possibly a very large number of stub may be required. When I'm testing unit-wise, especially in the top-down integration, I might require more number of stubs. That's one of the major drawbacks that I have here. Remember that. Especially if the lower level of the system contains many functional units. So what happens? What is the meaning of that point? Imagine I have this diagram. So in this diagram, if I have multiple functional units, multiple branches at that particular point of time, I might require more number of stubs. That is what you need to understand with this point. All right. So yes, moving forward to the next one. So guys, the major issues. Till here you understood the different issues that we have with respect to the top-down integration. So the same issues continues here. So what are the next issues that we have? So one solution to avoid many stubs. I was discussing we need stubs. So having the stub is very difficult and we need more stubs is what we have discussed in the previous slide. But now one solution to avoid too many stubs. Let's check that. What is that? Modify the top-down testing strategy. So you change the strategy of whatever you are you are having the integration. So change that strategy. Test each layer. So please listen here. Test each layer of the system decomposition individually before you merge the layer. So what is the meaning of it? So what we were doing, why do we need this stuff? So please listen here. So when I'm testing this, I need all the subsystems, whatever I have, I will be replacing that with the stubs. That is what I was doing. But let me change that to solve the problem. So only this layer you test. So you're not testing any layers which is below this. So that is the suggestion that they are giving. Whenever you are testing only this layer, so you are avoiding a lot of requirement with respect to the stubs. That is what you need to remember here. That is what they are trying to say. So whenever you are testing, only test this layer, only this layer. Don't go to the next layer. So if you go to the next layer, you need stubs. You need to replace the stubs. That's what you need to remember. So that's the most important thing that you need to understand. So that's a point. Moving forward to the next point that I have. Disadvantage of modifying the top-down testing is both stubs and drivers are needed. So that's one of the thing. What is driver? I will be explaining that in the coming slides about the drivers. I'll be speaking when it comes to the bottom up. Okay, I need driver. Top down, I need stubs. Remember that. So that's one of the drawbacks that we have with respect to this. If you have listened to my previous topic, that is top-down integration, this is just opposite to that. So instead of starting the integration from the high level, so I am starting it from the low level. So that's what you need to observe here. So what I have, so I have the low level units. First, I will test all the low level units, and then I go to the next one, that is the subsystem. So first I will test all my low level units, then I will integrate with the already tested subsystem. So then I will go to the next subsystem. I will be repeating this until I have all the subsystems in my program. So this is how I will be building the bottom-up integration. So that's what you need to remember. Let's take an example. So guys, observe here, this is my system. How do I build this? So first I will come to the low-level unit. So this is what I will call it as a low-level unit. And then I will move up. Then I will move up. So that's what you need to understand. This is how I start building the bottom-up approach. So guys, let's check some of the important points with respect to the bottom-up integration strategy. The first point that I have is focus on testing the units at the low level first. So that's what the first point they say. Yes, we have already discussed that. So gradually includes the subsystems which is already been tested. So that's what we have already discussed. And the last point that we have is repeat the same step until you have all the subsystems in your system. So this is the routine that you need to follow. So to have the bottom-up integration. Yes, my dear students, when I was discussing the previous topic, I was using the word called stub. So you all know that what exactly stub is all about. So I need the stub when I am performing the top-down approach. But when I am performing the bottom-up approach, I need a special thing called drivers. So drivers are required for testing. That's what you need to understand. So what exactly drivers are doing? So please remember, drivers are specialized routines that passes the test cases to the subsystem. Drivers are the specialized routines which passes the test cases to the subsystem. That's the main job of the driver. So fine, subsystem is not everything below current root module, but subtree down to the leaf level. That's the most important point that you need to remember. So fine. So what is that you need to understand? Whenever I'm performing the top-down integration, you need stub. But when I'm performing the bottom-up, you need drivers. What is drivers? Drivers is a specialized routine which passes the test cases to the next subsystems. That's the most important point that you need to remember here. So moving forward to the next point. So not an optimal strategies for the functional decomposed system. So that's one of the important points that you need to remember. Not an optimal strategy for functionally decomposed system. What exactly it means? So please listen. Test most important subsystem. Remember, test the most important subsystem. That's the most important point that you need to understand. When I'm performing the functional decomposition, first you need to test the most important subsystem. That's the most important point that you need to remember. More useful for an integration object-oriented system. Why do I need drivers? So it is more useful for integration of object-oriented system. I will be using the drivers for the integration of object-oriented system. Then followed by drivers may be more complicated than stubs. Drivers may be more complicated than stubs. So that's a major thing that you need to remember. This could be a drawback when it comes to the concept of drivers. Moving forward, less drivers than the stubs are typically required. So I might be required more number of stubs. You will be getting the answer for this statement. Sir, why? Because I will be replacing all the stubs with a lower level individual unit. But when it comes to stub, I will be replacing with the subsystems. Do you have more subsystems? Do you have more subsystems or low level unit? Yes, you will be able to tell me. Yes, obviously, I will be having less subsystems, right? So that's why I require less drivers than the stubs. So drivers will help me to integrate the object-oriented system as well. So that's the most important thing that you need to remember. And also, you will be remembering this point also. Test the most important subsystems. That's the most important point that you need to remember with respect to the drivers. Moving forward, the next concept. So you have studied top down. You have studied the bottom up, right? So what is the next one that I have? The next one that I have is sandwich. The next one that I have is sandwich integration. What exactly is sandwich integration? So guys, let's understand this concept in detail. What exactly is sandwich integration? Sandwich is a strategy in which top level modules are integrated with the low level modules or tested with the low level modules. So that's what you need to remember. What is the meaning of it, sir? I repeat this statement. So to all of you, please listen to me carefully. So sandwich is a strategy in which top level modules are tested with the lower level modules at the same time, lower level modules. What is the meaning of it? So both top level and the lower level are being tested at the same time. So that's what they're saying. We're not understanding anything, sir. Hold on for me. Okay, so please remember this. It combines both top-down and bottom-up approach. It makes use of both stubs and drivers. Sir, kya hai, sir? Integration of both top level as a bottom-up. What exactly that they are trying to say in the sandwich top level and the bottom level. So please understand. So they are trying to combine both the approach. Then how exactly it is working, sir? Yes. Look at the diagram that I have. So guys, so this is what I will be calling it as a sandwich integration. So it will be testing both top level as well as bottom level. So I'm not considering the entire structure here. Instead of that, suppose if I take this main system, so this subsystem which is connected to this and whatever the units that I have in the lower units, so I will consider this. This entire part I will test first. So this methodology is what I will call it as a sandwich. So please remember the points which I was discussing in the previous concept or the previous slide. So what was I saying? So I was saying it includes both top level as well as lower level. So it will be testing both at the same time. So this is what I will call it as a top level. This is what I will call it as a lower level. So I'm testing at the same time. So that's the first point that I had discussed. The second point which I was saying, it is a combination of both top-down and bottom-up approach. So top-down in the sense, first you will be taking the main program, then you will be coming to the subsystem. So you will be testing the subsystem. One layer you will test and then you will go to the lower level. That's what we call it as a top-down integration. But when it comes to the bottom-up integration, what you guys are doing? So first you guys were doing, you were testing the units, the last lower level units. Then you started integrating with the previously tested the subsystem. So this is what you were doing. So I'm merging both in this one. That's what you need to remember. So in the top level integration, I was using stub. In the bottom up integration, I was using driver. Since I'm using both the approach, I will be using both stub as well as driver. That's what you need to remember with respect to the sandwich. So guys, this entire thing, so this is what I will call it as, I'm testing this entire thing, okay? So this is what I will call it as a sandwich integration, all right? So you're performing both top down and the bottom up. So that's what you need to remember here. Less stubs and driver development effort. So that's the advantage that I have here, okay? So less number of drivers and the stubs is what I would like to tell you and highlight this as an advantage. Added difficulty in fault isolation. So when it comes to the sandwich, fault isolation will be a very difficult task. So that's one of the major drawback that I will have here with respect to the sandwich. All right. So whenever a failure is observed, the most recently added unit is suspected. Say for example, I'm performing the integration. So I've tested this, I've tested this, I've tested this. Okay. So there is a failure. So what is the point that I need to remember with respect to the sandwich integration? Most recented most recently added unit is suspected for failure. So that's what you need to remember with respect to the sandwich unit integration. All right, the integration testing is, please remember this, integration testing progress is easily tracked against the decomposition tree. It is very easy for me to track when I have the decomposition tree like this. So this is a decomposition tree, right? So it is very easy to track the integration. So when it is a decomposition tree, that's what you need to remember with respect to the sandwich integration. Moving forward to the next point that I have. So guys, so some of the pros and cons of sandwich integrations. So one of the most frequent, this is going to be very, very interesting. Listen to me carefully. One of the most frequently objections of functional decomposition and the waterfall development is, guys, whatever the sandwich integration that we have, this is for the management level. This is helping for the management level. So not for the coders. That's, I will call it as the software developers. This is not helping the software developers. Instead, it is helping for the management level. That's a most most important thing that we need to remember here. And the next one is the development effort of stubs or drivers is another drawback. That's one of the drawback that we have, of course. So we should have the stubs and drivers. Otherwise, in this methodology, we cannot have the integration. That's one of the known drawback that we have to accept it even in the sandwich. All right. So guys, by this, I have come to an end with the top-down, bottom-up, and the sandwich integration. So I will be discussing a lot of things in my next session, so which will be the final session of your integration testing. Till then, take care. Bye-bye.